everybody. Slides. Relay. My name's Alex Wilmer. That's me. I'm at Benevolent Ninja. Alex Wilmer. Alex-Wilmer on GitHub. Really into food, music. Love JavaScript. Big fan of JavaScript. So I got into JavaScript at a pretty opportune time, I feel. Like this was like 5 or 6 years ago. Angular wasn't out yet. jQuery was like the big thing. And I like was pretty fond of it. And I kind of felt like I was catching this really big wave where stuff was really just like it wasn't a big wave yet. Like at the time it was like this kind of little wave. Angular came out. ES6 was just around the corner. React and I feel like I've just been having like loads of fun the whole time. And like other people that I know have been in the industry a bit longer than I have, I feel like they're seeing this oncoming wave and just they're just going to get crashed by it. And then like, you know, React is too weird. And then at the same time, there's a lot of developers that are just starting and they're like on the other side of this wave and they see this like gigantic mountain that they feel like they need to climb, not sort of seeing that it's a wave. I feel like this is kind of just a state of mind and that we are all the circle of life. I work at the Ontario Institute for Cancer Research. Very, very fortunate to work there. It's an awesome workplace. I was looking for something that was more of a challenge, something that had cooler, newer technologies, and this was the ticket for me. So day one, I was working with a lot of this stuff. So we got React, there's GraphQL, Flow, static type shaper, Redux. It was like all Facebook stuff. I realized I was wearing a Facebook t-shirt today as well. I'm just like repping it. I think I was going to delete my Facebook account too. So I dug up some. So these are the very first 3 commits I ever had. And this is the end of 2015. And so like the last 2 commits already, I'm adding static types, and I'm changing some Ajax calls to use GraphQL. So that's pretty cool. This is like what that pull request looked like. On the left has some Ajax-y stuff, and on the right you have a GraphQL request. So I was like, felt like I kind of had a handle on it, but there was really a lot to learn then. And then one day, lead developers like, oh man, you should do Relay, JavaScript framework for building data-driven React applications, whatever that means. So go to the Relay website, get started. You need a GraphQL schema. Okay, well I didn't have that. I didn't know what that was. So okay, go to the GraphQL website. A query language for your API. It's like, what was I doing with my API before? Like I was hitting it before, so I didn't really understand what this meant. So I kind of like backtrack, thinking like, what are we even doing? Okay, what are we trying to do, and like, how are we doing it? This is a really stupid example, but it's a program. It's just a function. This you could say runs like a game or something. It runs sandbox on your computer. There's really no communication outside. It's just it's a function, and it runs in its own environment. There's like another scenario where you have sort of 2 programs that maybe run in some sort of similar environment or not, but they have some way of trying to communicate with each other. So they're introducing this kind of like communication layer in which one program can call functions in the other program. And then if you extract that, I mean, that's really like, oh, this thing fell off, sorry. This is really like the web. This is what's going on in the web. What do we want? We want on the client to be able to call a function on a server, and these are like completely separate execution environments. And like, how do I do that? You know, like here's a really sort of like the most common example. Client says, you know, hey server, I want you to go get some data and then send it back to me, and then I'm going to draw something on the DOM. And so now, you know, like there's these computers aren't connected. I mean, they're connected over the wire, but they're not running in the same system. Like, so we need to devise at least a language or some sort of communication layer to facilitate this kind of thing. And so like HTTP, right? So this is like hello world of client-server communication. So let's do that real quick. Let's just build a really fast server. Let's build something like Oh, that's not what I wanted. Oh, this looks good. Hey, look at that. So, so Express is just a web server thing for Node.js. You call it Express, and you get an app, which is like an bigger, yes. Say when. Okay. Right. So the server is sort of this is now we're kind of like creating the language. We're creating the communication on the fly. We're saying to whoever wants to talk to me and call this function, this one, go to this web address at slash, and that's going to give back hello world. Let's run this. Where am I? Was it basic? Oh, thank you. Basic. Oh. Basic. Basic. Oh. Address and use. Okay, let's change the address. I don't know what's going on there. 3002. Oh, yeah, don't listen to that. All right, we're on the web. So we go to localhost 3002. Don't trust my eyes. Hello world, it works. So like in a sense, I mean, this is all running on my computer, but theoretically, like I could be running this completely separate. And so this is how we're beginning the thought. This is the romance starting between the client and the server. So this is like the most absolute basic thing you can do, but let's take it up a notch. Ajax, get some data, and actually like do something with it. So I have some mock data. I'm going to use it for the rest of the for the talk. So I have data tb. This is not going great. That might be really big. Anyways, I have like something that represents kind of like a SQL table. So I have a links table with some IDs and URLs and description, and I have tags. So I have two tags, I have JavaScript and React. And I have this kind of like a join table, the many to relationship, like links can have lots of tags and tags can have lots of links. And I have this REST server. And so this is what a very small extension from what we just had, where rather than just have slash, I have sort of meaningful endpoints, they call them. So like slash links says I want to return a JSON blob of all of the links in the database. And then maybe I extend that a little bit. So I have link slash ID if I want to get a single one. And then if I want to get all of the tags associated with that link, then the convention would be, get me the links to that particular link, and then all the tags under that link, and then I do some fussy work here to do like a join kind of thing. This is not the important part of the code. And then I also have a post request, so I can add a link to my database. And this is sort of the communication. This is how it's going to grow. One thing you might notice here, I don't have any slash tags. So I would sort of have all of the inverse of all this to facilitate the reverse of that kind of thing. What does this look like on the client? So I have a little React application. Okay, I've got like a list page and a details page. So on the list page, is that size good for everybody? So okay. So when the component mounts, it's going to go. I have to make this little helper function hbget. Just makes a fetch request to the server to get links, and then it's going to get. So once it has the links, then it's going to loop over all the link and get all the tags associated with that particular link. And once I have all that data, I'll loop over my links, and then I'll generate some links, so then I can go to the details page for that particular link, and underneath I'll show all the tags too. So I should have this running somewhere. It's this one, 3,000. Cool. So that's what that looks like. Make sure that I'm running the right one. Yeah, so you can see like I went to links. I got all my links back. And then for each link, I went through and then got all the tags. And so I made, in the end, quite a number of requests here to facilitate this data. And then when I click on a link, it'll go to like a details page of that particular link. This is like super common type of scenario where you have some information on one page, and then you'll have more information on the other page. And yeah, oh, so while we're at it, let's also add a link or just some letters with a description. Beautiful. And then, cool, I made a post request somewhere along the way. I can't see here. And then, oh yeah, great. Awesome. The web, it works. But what do we do along the way, right? So this was like the language that we were building. We're communicating through URLs. That's like the main thing. The main language we're dealing with is URLs, and the methods, very important. We want to get some data. We want to post some data to the server. We want to delete something. And then sort of everything else is just something else, right? Like a complicated query string. Maybe I'm posting some like data objects that tell it what to do. But in that sense, it's like whatever the server does with that information is pretty opaque. Like all I know as somebody requesting data is that I'm asking for this stuff and I'm sending something, but I don't really know what I'm going to get back. And it's also, if you think about it, it's kind of limiting. Like the rest of the programming world is pretty way more malleable than this. If we want to do like anything, we have the whole programming language for us. But here we're like really stuck with this convention. And the other thing too is that we have this like map of URLs. Even though it starts off neatly organized, as time goes on, you have a little bit extra requirement. And then so you make like maybe a links and tags URL and a links and tags with only ID keys, and just like it just grows. And it's not that it's necessarily bad, but it's likely that things can get kind of messy. It's good for simple stuff. Complexity is hard to express. It can get disorganized. And it's pretty low level. Like we're not talking about the technology here. Like REST is just sort of a convention. It's like there's a spec sort of for it. I don't think people really know what the spec is these days anymore. It doesn't provide anything like validation or type safety. GraphQL. So GraphQL, if you type GraphQL versus REST in Google, you're going to get a bunch of results. So like clearly there's some overlap here. Like can we actually use GraphQL to do the same or better than we did with REST? So let's actually go to the GraphQL. I think I have it here. The GraphQL website. This one. So it says, can you guys see that? No, maybe? I'll read it. So it says, describe your data. Cool, so this is an example. I have a project. Something that says, ask for what you want, get predictable results. So that's already sounds better than what we were doing with REST, because we weren't getting predictable results, or there's no way I could guarantee getting predictable results. Things can error even in GraphQL too, but there's maybe something that we can do here that'll make that process easier for us. So query language for your API. Maybe this is starting to make a bit more sense. So let's get started. Let's just jump right to the code part. So this website is pretty new. It's pretty good. Everybody should check this out. Particularly because you can just grab these examples, copy and paste them right away, and get it to work, which is great. So what do we have here? We have a GraphQL library. We don't really know what that is right now, but we have from that we have a GraphQL is a function, and build schema is a function, and so it looks like we're creating a schema, which is just a set of like instructions or a set of way that we can describe what data is supposed to be. So we have a type, we call it query, and it has a field, hello, which is of a type string. let me pass that schema down into this GraphQL function. This part here, that's the actual query that if we were running a server, that's what we would send. And that last part, root, that says, what do we actually do with this information? So the way this works in GraphQL world is this is why it's ordered like this. The first thing you provide is the schema. The schema has to match some basic rules. In GraphQL land, they call this the GraphQL schema language or something like that, schema definition language. And so this second string, the hello, it's going to check against the schema to see whether it's valid. So in this particular case, that hello matches that field hello, so it should be good. And if the first part passes, then it's going to go on to this part called root. They say root because it's like a tree. There's like an entry point where it kind of comes in like that, and then it tries to figure out what else to do like from that, kind of like a JSON document. Another thing that they call these is resolvers, like resolver functions. So when you get to hello, there's a function that resolves to hello world. So let's try this out. I could just copy paste this, but I have it somewhere. Hello. Right? Same thing. Let's go to the next page. Node. Hello. Cool. So we got something back. So if we jump back to that code again, we'll see in the GraphQL function, so we had the schema, and then the query, and then the root, and then it resolved the promise, and we got a response, and the response was data, hello world. So it did what it said it was going to do, which is great. Let's play with this a little bit. Let's just add some stuff here. Like we have a query. What if we didn't call it query, called it query, and then we ran it. Oh, it didn't like that. Must provide schema definition with query type of type named query. Okay, knows what it wants. Back query. Same thing with fields. String with 2 G's. Doesn't like that. Type string not found in document. All right, let's add some other stuff. We don't need commas here. No point. Let's just do some random stuff. Foo, we'll say it's an int. And then down in our root here, we'll add a resolver for foo, and we'll say false, just because. And oh, that seemed to work. Oh, because I didn't ask for it. See, it's in the schema, but I didn't actually say I wanted foo. So let's take this part and make it a variable. Let query. Fussy with these things. Okay, foo. That's our query. Pass that along here. Run it. What? Foo, 0. That's kind of a surprising result, actually. What if I pass a string? False. Okay, it's throwing error. Int cannot represent non-32-bit signed integer. Very false. So this is pretty cool. We're getting type errors in our query. Tried to do that with REST easily. We can do objects here. Let's make a type of an object. Let's make a new type. Let's make a type person. Person has a name field, which is a string, and an age, an int. And then when we try to resolve person, we'll say resolve something that has age is 19, like me. And then name is Alex. Cool. And then we'll ask for, did I do something wrong?
No trailing comments?
Is that, no, it's actually complaining about an error. Unexpected token.
To wrap the...
Oh, thank you very much. You guys are great. Okay, so now I'll ask for person, and I'll say age. Let's see what we get back. Notice here is this is not going to work because Query is the root type. Query is the thing that represents this whole root object. So when I ask for a query here, it's going to hit person, and it's probably going to say person is not actually a field on query. Let's see if we can make it do that error. Errors, GraphQL error. It's not giving me a very, okay, here we go. Cannot query field person on type query. Great, this is good. This is what I want to see from a communication language when I'm interacting with something on the web. It's pretty nice. So let's add that. We'll have a person of type person. Will it work now? Pretty cool. Person age 10, age 19, I mean. And you know, we can ask, well, it resolved with both fields, right? It said person has age and name, but it only gave me back what I wanted, which was nice. So if I asked for not age, but just name, I just get just name. So there's a lot of different kinds of types. We have not just all the regular stuff like int, float, boolean, string, but you have person types, you have list types. If you check out the GraphQL docs on this page, whoa, types, type system. There's like really a lot of stuff you could do. It's like GraphQL, the language itself is, there's a lot more that meets the eye. We're not going to cover all of it. We'll just do like the basic stuff. Like we'll make an object. We'll have a list of objects. We'll add these exclamation marks to make sure things that are guaranteed that you have to have them. They call that non-nullable. It means that it's expecting the value to return not null, which is helpful for things like IDs. You can pass arguments to the resolvers, right? So I can say that the person, the name field can take first letter, and it could be a string, and then I can resolve, you know, just the first letter of the name, stuff like that. Pretty cool. All right, let's move on because right now we're running everything from the command line, and that's fun, but not super fun. So let's actually run a server, and this is not. Can you guys see the code here? So it's basically the exact same thing, but this time we're pulling in a middleware called Express GraphQL, which just says when you go to the /GraphQL endpoint, you know, do that validation process we were just running on the command line, but like as we're sending requests to it, which is going to be great. And there's like some secret sauce here, which is this Boolean value graphical, and we're going to go check that out because it's rad. So I have this open here as GraphQL basic server. No, GraphQL. So in here I pulled in my links and my tags. So I have a type for link. Again, holler if it's not big enough for you guys. So link has an ID required field, has a URL, it has to have its string description. And then here I have something interesting. I'm creating a relationship. I'm saying that links have a field tags, which is a list type of the object type tag, just declared right below it. And vice versa, tag has a links field that's a list of link objects. And then down in my query, I have links and tags, and I can pass in an ID if I want to do something with that, like filter them out or something. And then I expect that to return a list of links or list of tags. Conversely, I have some other stuff, I'll get back to it. Here's the resolvers that we were just kind of looking at before. So if you hit root links, you can pass an ID optionally. If the ID is there, it'll filter that links now. Otherwise, it will just return the links. And I made a little handy join function because if you remember, this was a table style with like a join table kind of thing. Not important, but that's what it's going to do. And then down here, I have what you saw before, app use GraphQL, which is that middleware that's going to take the thing that I send it to it, validate it against the schema. If it passes, it's going to go through the root value. And so we're listening on 4001. Check it out. Slash. Whoa, what's this? So this is graphical. This thing is amazing. So just by having written that schema, that type system, it is being served. It's called introspection on my type system. I can now query my type system, and it can tell me what my language is. It's like, you know, I would love that for a REST API. Right now, the gold standard for REST APIs is go to the docs. And this is like, the type is the docs. It just works like that magically. It's got some other cool, so on the right-hand side here, there's a little docs panel. And so it says here I have this query type where I have links and tags, and I can see there's a type link, and a link has the ID URL description, tells me whether it's required and stuff like that. That's great. And on the left-hand side, I've got this little query panel. Oh, it's giving me validation errors like Microsoft Word or something like right off the bat. So I have query, and then I want to say, oh, autocomplete on links, and get me the URL and the description. Run this, awesome. So now I got the links, the URL description. This is pretty great. Let's see if the tags thing has worked out nicely. So I want to say on this particular link, like on a per link basis, get me the tags with the name, sure, ID, and run it. And great. So our JavaScript has the tag JavaScript. Our React has both JavaScript and React. And if it's not immediately obvious to people that are doing REST for the most part, this is not a query that you can easily do in one request with REST. I mean, you could make an endpoint that's a link and tags endpoint and a tags and links endpoint, but then if you have like lots and lots of these types of relationships, your API starts to get crazy. And with this cool type system, instead we're describing the relationships. So this is really why they call it GraphQL. GraphQL query language. We're not talking about databases. We're not talking about graph databases. We're just talking about relationships. Like JSON. JSON is a graph. A tree is a graph. A graph is just you have some data and you have some lines that go from one item in the data to another item in data. Typically, they will call these nodes, and there are edges between the nodes. I think that was my next slide, I think. Whoa. Come on. Oh, yeah. Are these like internet connection or something? Oh, c'est la vie. Did I really? Nope, Reddit's still going. Oh, it's going so slowly. GraphQL. Yes, why is it called graph? Because it's like this. You have nodes and you have edges. And this isn't what the data in the database looks like. It might, but that's not the point. The point is that I want to be able to describe how I want to interact with my API. Like, I just want to, as a consumer, dictate what the relationships are in a way that makes most sense. And graphs are very convenient for defining relationships in that sense. So yeah, so let's take a look at this again. So you need three parts to set up a GraphQL server. You need that strongly typed schema. You need some sort of query to actually parse and validate that schema. Then you need sort of a map of resolve functions. Like once that schema is validated, you actually need to go and do something with that information and go to the database. And at that point, we're just calling a function. This is sort of why I was pointing that out at the beginning, is that this isn't specifically speaking, going to a database and getting data. Like maybe that's a super common use case, but maybe I want to actually call out to another API. Maybe I want to, I don't know, do some work. There's a really cool example in the GraphQL docs where it's like a dice rolling game. And so there's no data at all. It's just you're using the GraphQL language and the interface to like play a gambling game or something, which is cool. Again, it just functions. So this part is really important to remember, that this is a powerful communication idea, right? And that's why it's useful. And so to complete the server, you need some sort of actual server. So like that's kind of a middleware or an endpoint. Very typical, you'll have a single endpoint, very commonly referred to as /GraphQL. And then it will receive typically a post information that has what the query string can be, but it doesn't have to be like that. GraphQL schema, very important part. So as we saw, it requires an entry point node, so they call that the query type. And then you can have objects, you can have list types, scalar types. I actually asked somebody smart why it's called scalar types. I don't know. String, in, float, boolean, ID, which is like a special unique type. Non-nullable, exclamation mark. You can pass parameters. There are other stuff I didn't get into. So interfaces, if you have like a character type and like a hero type, they might both have names, but you want to resolve them individually, or you don't want to have to repeat all the fields all the time. So you can do some stuff with, there's like union types, there's enum types if you want to just define like a few types of things that are in one type. Queries, so you saw, we'll go back to it for sure. Kind of looks like JSON, but it doesn't have the value part. It's just a bunch of keys. You're basically saying like, I want this object with these fields, and it doesn't discriminate in the way that the query looks, whether it's a list type or whether it's an object type. You just say like, this is the thing I want, and these are the subfields I want, and so forth. You can pass arguments. Directives is not something that I'm going to talk about very much, but it's like special annotations on the fields, basically. So the ones that come included with GraphQL are include and skip. This is super useful if you want to define what a query is going to be, but you don't necessarily want to run it right away. So you can say include if some Boolean value. And then in the actual query part, you can have, like, so I said, you can have an interface where multiple object types have a lot of shared fields. That's when you're defining the schema. And on the reverse side, if you're wanting to ask for a bunch of different types and you want all of the same fields, you can define a fragment, and then you can sort of spread that the same way that you do like an object or array spread inside the query, so you don't have to retype all the fields all over again. And then the piece de resistance, the stuff that actually does stuff, the resolvers. So this is just like a map that meets the schema criteria. Go to database, call a REST endpoint, whatever. Of course, functions don't always work. It should return what the schema says it should, but errors happen, and so the error it'll actually get propagated up. Let's do that real quick because that's useful to see. So here I had links. Let's just like throw an error right away. Throw. I can't spell. Doesn't matter. Oh, comma. Do I have to actually put braces? And then 4001, you up. So I think this was it, right? I was asking for links. See what happens. Oh man, errors. So this is good. This is really good because then as an application developer, as a server-side developer, you can give a lot of feedback to the person that's writing it. Like, look what it said. It said that it gave me the path to the links. So if I threw an error on an inner node or an inner field of it, then it'll say not only did it error in this particular way, however the developer wants to say the error happened, but also it knows where in the query it errored, which is very, very useful. I mean, that is not an easy thing to accomplish with a REST call because you don't have that sort of inherent structure and there's no built-in relationships to what you're doing. So again, this is not like knocking on REST, the technology. This is just saying how in a world where we have more complicated client-side requirements, GraphQL is a really good system. It gives people like me, who are predominantly front-end developers, more wiggle room to make sure that I'm getting the stuff that I want and not the database guy is giving me whatever he wants. Moving on. Okay, so schema, queries, resolvers, got your GraphQL implementation. So one thing we didn't really touch on here is like, what is that GraphQL function? Right, like what is that? It just is some library that I'm using. Well, so GraphQL, very similar to REST, is just a spec. It's a spec written by Facebook. Let's go here, spec. So this is a pretty hefty document, so we'll sit here and read through the whole thing now. But it goes through, like, you can see everything, like type, introspection, validation, execution. Execution, I think that's an interesting part. Not only does it tell you like how the type system works, but it gives, it's concerned about the way that you actually write a system that is supposed to behave properly. It's not like, REST doesn't really have that, as far as I know. I mean, it might, but certainly if it is, nobody follows it. Like, so that being said, the GraphQL function that we're using in Node is implemented in a lot of different languages. As far as I know, GraphQL probably is implemented in just about every major language now. You can probably take a look, but this is TorontoJS, so let's not. Pros. Expectation to receive the desired result. This is good. This is really good. And if I don't, I get pretty good feedback about what happened. So I can retrieve complex shapes in a single request. I get instant query validation feedback. So I mean, that's not on this list, but the major pro is that graphical interface. You can run that together with your actual website. You can serve your API to people that want to just look around in your database through graphical. And that doesn't mean you have to expose everything, right? It's just a regular HTTP request, so you can secure it with auth tokens or whatever. But it's good to just get that immediate feedback. That was like one of the first things that I was introduced to with GraphQL. And so I was like mind blown. I think I spent like weeks just saying like, you guys gotta check out graphical. This is the thing. So it's organized, gives more control. I was just getting on that. Cons, it does require some more work. So sometimes I feel like people see the graphical stuff and they see the type stuff. They don't realize that you have to write the resolver functions, right? Like all the stuff that you were writing sandwiched between those REST calls that actually did stuff, don't get away from that. Like you have to write the stuff that does the joins or whatever. So because it's like this tree structure where it's resolving over things kind of recursively like a tree, it's not at all unlikely that you're going to be hitting your database more often than if you had a single endpoint that was going to do something. So we're sort of making a trade here. We'll have something that makes more calls but hits our database sort of a same number of times, or we're making one single call and that one call is going to hit the database a whole bunch of times. This is, I want to say, a mostly solved problem, I suppose. It depends. Facebook, so they're really championing this whole thing. They have a thing called data loader. It's just all of the stuff that they do with GraphQL doesn't touch any database layer at all. It's just description of what they eventually want to do. And so they kind of batch requests. So if they're going to do like 1,000 resolves on a nodes or something, they don't actually go to the database 1,000 times. Harder to cache. Maybe this isn't true. I think that I just heard that we just solved this. So come talk to me later about that. Yeah, so introspection. This is a really, really important thing about GraphQL. It really sort of is the thing that allows stuff to be built on top of GraphQL. You know, if you want to write sort of a language or a plugin or something that makes it work with the language that you've set up, you know, it's not enough to be able to figure that stuff all out at runtime. You need to be able to sort of have a handshake with whatever it is that you're trying to build ahead of time, and being able to ask your API, what are all the possibilities that I can do? That gives some really powerful concepts, like now, like on top of caching, but you can build entire programming languages on top of your type system, and we're going to see some cool ways to do that. But before we go on, let's look at what the front end. So we were looking at how our React app looked with REST. Let's see how it looks like with GraphQL. It's not that different. So here, same thing. I've got my app with my 2 routes, my list page and my details page. And on my list page, So instead of, maybe I get them side by side here. Well, it doesn't matter. So before I was just saying like HTTP get links. Well, here I'm just passing this object with a query on it, and then this string that looks exactly like a GraphQL thing that we were using in GraphQL. And it works exactly the same way, so I think this one's running on some really wacky port. Oh yeah. Oh, you know what? Didn't I just make it all fail on purpose? GraphQL. Try again. All right, it works. So if we look in, before we were seeing a bunch of requests to like /links and /tags. Now we have just 2 GraphQL requests. No, just 1. I lied. And we have here our, oh, that's not very useful. We have our data with our links and our tags. And so we're making one single request for all of this stuff that we need for this page. Where before we were making, I think it was like 6 or something. Same thing with going to a link. So we have our details page. How does that look differently? So we have, you can use the network tab to inspect things. It's pretty useful. You can click here to see what was the query that we were actually passing. So it's a link query. We're asking for some stuff. And you'll notice there's this little ID, $ID thing. So one really convenient thing you can do when you're interfacing with GraphQL is that you can have variables that are not hard-coded variables. So if I have an argument that I want to pass to a query, I don't need to write the query and know exactly what that argument is ahead of time. That's particularly useful for things like grabbing the variable from the URL because I want to get the link of ID1. What does that look like? Details page. Just bits. So I have my query for link query, and I have this $ID. So at the top, I'm actually, in this little section here on line 11, I'm actually defining the type of the variable that I want to pass. And in this case, so like ID is a special type in GraphQL. It just means that it's going to be unique. And then I'm actually, so here I'm defining what the variables for this query are going to be and what type they are. And in this case, it's required. And then here under links, this is where I just would normally be passing an ID. So in this case, it could be something like 2. But I don't know what it is ahead of time, and I don't want to hard code it in my string query here. So I pass 2 fields to GraphQL. One is the query, which is just the string thing. And then the other is variables. And the variables are going to have a one-to-one relationship to the things that are defined at the top, all the particular types of variables that I can have. So this is a child of a React router route. So when it mounts, it calls this GraphQL function, which is going to make an HTTP request, makes this query, sets this ID to be whatever is in props match params ID, and it's going to get just that one link, which is awesome. I got that one. Got that one. Sweet. All right, this is where things get a little bit hairy. Relay. I realized I already had Act 3, I think. Anyways. So everything that we just did is pretty manageable. I highly recommend going to the GraphQL website, copying and pasting some of those things into your favorite programming language, JavaScript, and just playing with the type system. Anything that you were doing with REST before, try checking it out with GraphQL, or go crazy, look at the dice example, make a game, do something that's not specifically like resources and entities, that kind of thing. So if you recall, Relay is a framework, a JavaScript framework for data-driven React applications. So it requires GraphQL, as we saw earlier. And so where does it fit into this? Where on this very simple thing that we were just doing, like where is it? What does it do? This is actually kind of a complicated thing to answer. So let's take a look at a problem that it's trying to solve. So problem statement, how can a React component fetch all the data it needs from the server to render properly and make sure not to overfetch common fields that a different component needs or ones that have already been fetched previously? What do I mean by that? Okay, imagine you have these two components. Can you guys see that right? Sorry, I keep asking, just I'm nervous about it. So I have a sidebar component and a header component, and they have different titles, but they both want the username from whatever my API is, and I want to render them on the same page. And how do I make sure, or like, what would I write if I wanted to be able to use these things independently, but I also wanted this component itself to be responsible for actually like initiating the request to go to the database. I think if we were doing this without any fancy relay magic, we would probably have a parent component which would on mount or something dispatch an action or make a fetch request, and then it's going to do that once, and then it's going to pass that props down to both components so that I only made the request once. But we don't want to do that. That would take away where we're declaring we want to get the data from. We want to get the data from the same place where we're actually using the data. So what they say, co-located queries. So in Relay world, we import Relay from the React Relay bindings. We have our components just the same way, but then we wrap it in relay.createContainer. First argument, we pass the component. And the second one is these fragments. And these fragments look kind of funny, but the general idea here is that these are little snippets of what a GraphQL query would look like if it were embedded in a big GraphQL query. So earlier I was talking about fragments, where you're kind of like spreading things into a query. So this is why it's called fragments. So this component now, which is now a relay container, not to be confused with a Redux container, says this is how you retrieve the stuff from the database or from my API, and this is how I'm using it, this is how I'm displaying it on the same page. And so you can see that both of these things are both asking for user and the username. But right now, this wouldn't do anything, because a container on its own in Relay is not enough to actually do anything. And just like any GraphQL query, there can only be one entry point, the query. So in this case, we would have to wrap these both containers in yet another container that will be the root one. You can see it says fragment on root, like what was before, which was query. And so here we import those two containers. We display them the way that we would want to display them, header and sidebar. We also, at the bottom, where we have this is our fragment as well, where we're not specifying that we want username here. We're just saying whatever those child containers wanted, just put whatever the fragment was. So here it says get fragment user. So that is the same as fragments user or fragments titles. So I have fragments user and fragments titles. And then I'm passing that down from the wrapper props to the header and the sidebar props. And this still, again, containers aren't enough to do anything in Relay. So we will go one step further and we will create a Relay route, not to be confused with a React DOM router, or sorry, React router route. This isn't a URL route. This is more like a river route. This is describing where data is supposed to flow back into our app. So I'm defining a route for my app, and then it's going to, this is the real key part here is the part that says query and then viewer. So if you remember all the queries we were doing before, like in the graphical thing, it all started with query something. And so this is a query, this is the top level one. And then we're going to pass this app route into this special thing, relay render. Oh. And then you guys have all seen React DOM render. If you haven't, that's how you basically initiate an entire React application. And so this is where you would normally have your app. And so instead of app, I have relay.renderer. And the container, I called it wrapper. I should have just called it app. And then I have my app route. And so this is going to sort of kick everything off. And attach it to that DOM road, development by ID. Does anyone have any questions about this at this exact stage? Okay. So what's happening in the relay lifecycle? So we mount that relay.renderer. We call React DOM render on it. So that's going to set up what's called the relay network layer. You'll notice nowhere in my code did I say fetch something or get this or that. Relay wants to abstract all that stuff out for you. So by default, it creates a network layer which assumes that you're running a server on the same port at /GraphQL, which is why it's a good convention if you're doing that. Of course, you can set it up to do anything. In fact, you can completely write your own network layer if you don't want to use, as it uses fetch natively, but you can have it use whatever you want. It's a good place if you're using authorization headers, if you want to pass some stuff there. And then it's going to pass that relay route, that little class that we made, which knows what sort of the shell of the query is. So it's going to combine these two things, the network layer plus the route, so it knows how to do it and where to go once it gets the data. So the next thing it does, pretty interesting, is it's going to recurse down our component tree or our container tree, and it's going to look at all those fragments. So we have header.getFragment and sidebar.getFragment. And it's going to go down and it's going to pull it back up, and it's going to construct that big relay query that we want to do, or GraphQL query, sorry. And you'll notice that now in this case, once I've constructed my whole query, I'm not asking for a username twice, even though I have two completely separate containers that are asking for it. I'm not asking for it twice because Relay's gone down and figured out what everything in the tree needs so that it can only construct one single query on behalf of everybody and then pass it back down. And so that's what happens. It creates a sort of a virtual query. And then this is the whole Relay magic part, and I'll show you this in action. It does sort of like a React does a diff on the virtual DOM. Relay is doing a diff on your GraphQL queries. So if you already had a previous query that came back, and you already had username, and you just wanted one more field, then it says, oh, I already got this. It's in the Relay cache. You ask for the data exactly the same way you want it, but Relay is going to be smart. It's going to make a GraphQL query only for that one missing field that you wanted, and then it'll give you back both fields, but one came from the server and one came from the Relay cache. And so this saves a lot of bandwidth, especially if you have really big queries. So then it actually does the work. It sends a fetch request to GraphQL with the diffed query. The data arrives, and then it starts passing props down to the child fragments. And then the child containers, the ones that actually ask for that fragment, they're going to kind of figure out in the container stage whether the prop that they were passed is the one that was carrying the data that they were expecting. And if it is, then it goes to the cache and it gets that data that they wanted. And there's one step here that I didn't show because it has to be just a bit more complicated, is that Relay actually needs to run at compile time. There's a Babel plugin. So when you were looking at these relay.ql things, relay.ql is filtered through a Babel plugin. It's doing a transform. It's going to say, look at this query, and then run it against the published schema. And this is why the introspection part was really important. Because we needed to be able to, ahead of time, know what our schema is going to look like so that Relay can make sure that our queries are actually valid before we even run our app. Which is awesome, because then you start your app and you don't need to go to the database to get a bunch of errors. It just says right away, like, this is not a valid query. Like, are you sure that you didn't actually mean this field on this type? Which is really cool for just requesting data. That's why the whole package with Relay is really providing a lot. But because of that, it does require that compile time Babel plugin, and there's a little fussing with it. It's all in the docs, hidden away somewhere. If you're gonna, well, we'll get back to that. There's a getting started to guide. Don't follow it. Just download the example. All right, so where does Relay fit in? So we got that Babel plugin. So that's the first thing that happens. We have the network layer, which is going to describe how we actually get resources and what to do with them when they come back. We've got the renderer, which it's the thing that we actually mount. It's the actual Relay stuff. And then we have a whole bunch of Relay containers. And then there's one more thing that didn't come up yet, is because Relay actually expects that your GraphQL schema is written in a particular way. It's not a huge change, but you can't just write any old GraphQL schema. It has to conform to some Relay-specific thing, and that's also written in the documentation. But again, if you want something that works and you're not going to lose it, then just download the getting started, like the simple starter or whatever it is. Okay, that's the end of my slides. All right, let's run some Relay. Let's actually see this in action. So, like I said, super highly recommended when you go to this getting started. When you get started, you just forget everything that it says here, and then you go directly to the Relay Starter Kit. I'm not totally joking, but like try just get this first and get it running, and then go back and then start reading things for it to make sense. There's a lot of code here for something that seems quite simple. But let's take a look at it. So in this relay section, and it's hard to even know where to begin, but let's begin with the database. So I have the same thing. I've got these links. It's just the exact same structure that I had before. I don't want to change anything for the purpose of this thing. And now this gets it. Relay wants to be able to know the instance of the type of the thing that it's resolving. So that's why it's using an empty class as a convention, because it's easy to run instance of on it to get the name of it. We have some mock data viewer. I'm not even going to get into it. But links, the same thing. So I'm going to loop over my actual database links and then create these classes on it and fill some information on it. Same thing with tags. And then here I have a whole bunch of accessing methods to get the data back from the database. This is something like the resolver stuff, but this is like the very last piece of it. This is the thing that the resolvers resolve to. The schema. Now, before you saw me write this type schema in a string format, the GraphQL schema definition language. It's cool, but it's strings. It's useful to prototype with. It's not useful to use in a serious application for any number of reasons. So this is probably, if you look into GraphQL stuff in the wild, this is what you're going to see, or at least for Express, but almost every implementation, like we do Python at work, and it's pretty much the same thing. You have a bunch of these types of things that are functions that return metadata about the types and other things like that. And so again, this is like the hello starter kit. There's so much to parse here. So like, let's just bear with me. Like node definitions, 6.6, this was my feelings about it, I guess, when I was logging this. This is where I was saying I want to have instance of types, so yeah. User type, this is a little bit easier to parse, but let's look at links. So I have a link type. It's got the fields. It's the ID, URL. Here you can add extra things. The description as well. When we were looking at that graphical, when you're looking at the docs section, this description will actually show up there. So not only can you know what things there are, but you can also get information about what those fields mean. You can get deprecation warnings here. That's awesome if you're upgrading your API and you want people to be able to see it really fast. So 3 minutes? Okay, perfect. I can end this in 3 minutes. Right on time. So anyway, so this is like roughly, and then here we have our famous query types, so query fields. This is node viewers, this is relay related stuff. Mutations, I didn't even talk about that at all. That's good. This is our app. So you see the same thing, right? I've got my list page and my details page, but it's a little bit modified because I need to make those that route object to know what to do with stuff. And here I have my viewer container, my outside one, and it just wants to get the list page fragment. So let's look at the list page. Cool. It is almost the exact same. Oh, this is not the right one. List page. Right, so now list page doesn't need to be a class anymore. It doesn't have any mounting logic, right? Because all that stuff is going to happen in the relay container. So the create container has my list page, and it's describing the fragment that it wants. It wants links. Relay, I said, adds some extra stuff to your schema. So now I've got edges and node. But same things, I've got ID, URL, tags, edges, node, all this kind of stuff. So let's just run this, and let's just see the magic in action. I think it's running already, but. Doing some stuff. Cool. What URL was it? 3333. All right, let's look at some useful stuff here. So when we run it, we have our GraphQL query. In the end, it returns the stuff we want. It has got the links and the edges with the node and the tags and all this kind of stuff. But remember, the important part that I wanted to show here and what Relay was all about is that I asked for all the stuff. I'm asking for ID, URL tags, node, all this kind of stuff. When I go into one of these links and get the details page, there's only one thing missing. I've already asked for the URL. I've already asked for the tags. The only thing I'm missing is the description. So if I clear all this stuff out, and then I click on here, I have a GraphQL, so it worked. And then I check out what fields did I actually ask for. Boom, just description. So it already knew that I had those other fields in cache. It did a diff on what was in my cache, and then it constructed the most minimal amount of query, just like React creates the most minimal DOM changes. Ta-da! I'll be around. I think some of my colleagues are still here, and they're also Relay and GraphQL experts. So.
Do they want to wave, maybe?
That's up to them. There he goes. Do I have time for questions, or does anyone want to have a question?
We do one or two.
One or two? What's up?
What happens when the server-side data changes?
When the server-side data changes.
Cache, how does it know what to go get in the data?
So cache invalidation is not an easy problem to solve any way you slice it. Relay specifically, there is a force fetch flag that you can dynamically pass. So I can imagine a kind of cool scenario where your API data changes, you have some sort of socket set up, and then you get a socket message that says you need to flip that flag to be true so that you get new stuff. Also, if you change your schema, there's a function that you can run that updates, because remember it publishes that schema to a JSON file that it uses to do all this magic stuff. So there's some work to do, but I think that there's a lot of really good answers for that. I think in the most minimal sense, at least you can do force fetch, and you could always just do a hot reload or whatever it is. Yeah. Very good question. Excellent question. So I went soul searching for a long time, probably 2 months. If you type into Google and you just say Relay and Redux, there's one particular GitHub issue, I think it's on the Redux page, that says, okay, cool, I don't need Redux anymore, Relay is out. And even Dan Abramov, the guy that made Redux, was like, I guess you could use Relay and Redux together, but I don't know why you would. And so I'm thinking, well, this is Dan Abramov, he must know what he's talking about. And I banged my head against the wall for so long trying to figure out how to, when a relay container gets put down, and as it's doing something, how do I show a spinner in the top left corner, like a global thing, that I would have done so easily with Redux, right? I say component did mount, dispatch in action, dispatch show spinner, when it comes back, dispatch spinner go away. And now I have this scenario where the fact that the spinner is up is not something that's coming back from my server. And I have everything siloed in these containers. So the whole concept of global state combined with this relay caching stuff was really hard to grok. One day I just said, screw it, I'm going to use them both. It was really easy to conceive of how to write that code because you have your wrapping relay container. And on the inside, you have a connect call, which just gives you dispatch and does all your stuff, gives you state. And one day I asked on Discord or something hey, does this look sane? And people were like, yeah, relays for your data state, and Redux is for your app state, modals, whatever. So yeah, I think they work in concert very well together. Yeah. Ooh. So how many, put your hand up if you love React. Okay, it's half of you. How about people who are lukewarm on it? Okay. So I've spent the vast majority of my time hating Relay, just despising it. But it's super cool. It's just a matter of me figuring out what it wants me to do. Yeah, I don't have a great answer for you. Like, check it out. I feel like it's just its early stages. Also, not only that, but Relay 1 is not out yet. So I think it's coming out in the summer. They just said something about that at ReactConf. Ask me again in a few months, but I'll say this for sure. It saves a ton of potential error surface, right? Like, it causes you to fight with it to do the right thing constantly, but that's kind of like a strongly typed system. You know, it's making you work harder, but then you don't have spaghetti code. Yeah. Like which part? Sorry, what would I be replacing with it? Which part? Did I? Not in the relay code. Like on the server side, I had some resolve functions, but so I think that to generally answer that question, like Rx is like a tool set, like Lodash. It's really easy to just intersperse wherever you need it. So if you want to, RxJS is really good for doing like time-based operations. Like you have to do like sequencing or buffering or delays, or want to manage things in parallel, or you want to do transposition, kind of like transducer type things where you have like stream processing. There's lots of stuff you can do with it, but I don't think that it would get in the way anywhere. So if you wanted to, go for it. Okay, I find me after. Thanks.